Hello everyone. Just coming out of a mental breakdown. All right. We are going to be just fine. All right, so I'm actually going to do a quick review, and then I'm going to continue on with what I was working on last night. So last night, I was really basically honing on the whole idea of the difference between arc measure and arc length. So, the arc measure, if you recall, it involves the center of your circle. So, if my central angle is 120 degrees, that means the arc length is 120 degrees. If the measure of the arc is, say, 40 degrees, that means the central angle is also 40 degrees. So once I know what the measures of the central angles are, I'm able to figure out what my arc measure is. Now, this is going to be different from those inscribed angles that you usually have to double or to take half of. The only reason why you would do that, I'm going to see if I can use this. That's my circle. So if I had a circle and I want to get the angles from here to here and from here to here. Okay, so say that this is, 60 degrees. Okay, so they're saying that the arc measure is 60 degrees. So this arc measure is not also going to be 60 degrees because my vertex is on the circle. So that's why we always say it's 1/2 the measure of this arc. So the degrees of this tiny little angle right here, I'm going to put an arrow to it, is actually going to be 30 degrees. Okay, so this is different from central, using a central angle, because if the center of your circle, let's say, is somewhere around here, I'm going to say this is circle K. Okay, your central angle is right here. So in order for us to get this angle here, I have to take half of the arc measure. Now, what I was mentioning last night is there's a difference between arc measure and arc length. So arc length, when you're taking a look at the arc length, you're actually taking bits and pieces of the circle. So the measure of a circle is 360 degrees. So if we're looking at part, okay, if we're just looking at part of the circle, we're just looking at how long. We want to see how long it is from J to K. And that means we're looking at the circumference. So the circumference is just that outer layer. So if we're looking at the arc length, we got to take part of its degree and multiply it by the formula of the circumference, which is 2 pi r. So we did a couple examples of those, but I left one behind. So I'm going to show you exactly how to find that arc length, okay? So they want us to find the length of AC. Now also, there's two different types of arcs. There is a major arc and there is a minor arc. No, I will not do. So we have the minor arc of AC. Anytime they give you just 2 letters, that means they're looking for the minor arc. Because if I try to go AC this way, this is called a major arc because it's more than 180 degrees. Plus, I had to go through B in order to get to C. Major arcs, they name it with 3 letters. Minor arcs, they name it with 2. So they actually want you to go from A to C this way. Okay, so they're talking about that highlighted arc right there. No, I don't do linear algebra, sorry. Hello, film artist, how are you? Okay, all right. So Gator, you think it's 150? All right, let's see. So we're looking at, they're giving us a diameter. Okay, so this is a lot of terminology that I was using last night. So I just want to kind of do a quick refresher before I get to the next part. So the diameter is a chord that goes through, or a segment that goes through the center of the circle. So the diameter, they're indicating it's 28 feet. And they're saying that this angle over here, this angle right here is 30 degrees. Okay? So, in order for us to figure out what the theta is that's going to be associated with this, we need to find this unknown side. And I'm going to put it, I'll put it in pink. So we need to know the angle for this. We need the angle measurement for that. So we need the theta for that. This one, the smaller one, is 30 degrees. But this one has to be how many degrees? Okay. So that's why Gator, good. Okay. Atari, yes. Good. That's how we get that. Yes, that's how we're getting that 150. So we can kind of make a little notion. So we know that our theta is equal to 150 degrees. The reason why half a circle is 180 degrees. If the whole thing is 360, we divide by 2, so we get 2 halves of 180. We knew that this part here was 30. So 180 minus 30, that's where the 150 came from. Okay? So we have our theta. Now the other thing that we need is our r, which is our radius. So they're telling me that the diameter is 28. And how do I know? They drew a long chord right smack in the middle of the center of the circle. So if that whole thing is 28, my radius is going to be, love this. Okay, Brandon, Daniel, Atari, good. All of these with the 14. Because 28 divided by 2 gives me my 14. And I'm going to write 14 feet just to remind myself of the measurements. You just had your SAT? Good, Sam. How did it go? Okay. So now, we want to find the arc length, not the measure. If they said the arc measure, then AC would equal the 150. Then we'd be done. Boom. But they're saying they want the arc length. So that means we're going to take part of the whole circle. So the part is 150. The whole circle is 360. Times, now since we just want the length, that means we're looking at circumference. Circumference is the rim, okay? It's the perimeter of the circle, okay? It's the outside. So the formula for that is 2 pi r. And we know that our r is going to equal 14 feet. Are we good so far? Yeah, the second one is usually a little bit harder. Yep. Because what happens is they give you the first part and then you do some stuff and then you come back to the math and you're just like, I'm already exhausted. So your brain is just bleh, right? Okay. The ratio of the unknown length to circumference is equal to the degree measure over 360. Awesome. Lovely. All right. So you're saying, so Brandon is also saying 28 pi. Oh, hello, Brandon. All right. So we got our 150 over our 360. And we're multiplying it by, I know, it's like our 14 squared, which almost looks like, let me just get my diameter. Because remember, that's also an option. So we could do this right here one of two ways. We could multiply the numerator with the whole number, or we can do what's called cross simplify. Okay, so you're not dealing with such large numbers. So since 28 and 360 are both even numbers, I kind of want to tackle it. I want to tackle it, see if I can simplify it this way. All right. So 28 and 360. Well, I know with 28s, we've got multiples of 2s, got multiples of 4s, and I think I want to try the 4. So if I divide this 28 by 4, that's going to give me a 7. If I divide the 360 by 4, that will give me a 90. So now I'm kind of lessening it out a little bit more. So all I would have now is 150 times 7 pi, which gives me 1050. And I'm going to put my pi. Okay, let me unzoom just a lot. And then what's left in the denominator is 90. Okay, so if I have my 150 over 90, this is a little trick that I have. If they both end in zeros, we can cancel out the zeros to make the numbers even smaller, all right? Because sometimes a lot of us just get intimidated by the large numbers that we're just like, I don't know what's going on, all right? So now you have 105 pi over 9. They're both odd numbers. And one of the numbers that I know that has odd, that means multiples of 3s are being involved. So if I divide 105 by 3, what do I get? Okay, so what do I get? 105 divided by 3. Because I want to reduce these fractions. Okay. Yes. Hey, Lisa. Good. So 105 divided by 3, that'll give me 35. And then 9 divided by 3 will give me 3. So I know if I tried to divide 35 and 3, I'm not going to get a nice even number. I'm going to get a decimal. So then I'm just going to tack on my pi. And for my exact answer is going to be 35 pi over 3 feet. Okay, so since we're looking at the length, it's just going to be feet. Now, if I'm going to look for the area, it will be feet squared. So this is my exact answer. If I wanted the approximate, I would actually divide it. So I know a lot of people are like, oh, why don't you just use 3.14? Pause. Pi is not exactly 3.14, right? We all know it's an endless bunch of numbers, right? So in order for us, if they say to use 3.14 and place a pi, do so. If they say give us our exact answer, this is your answer right here. But if they say an approximate, you're going to do your 35 pi, then you're going to divide that by 3, and you're going to round. And they'll tell you approximately, and they tell you where to round it. So let's round to the thousandth position. So if I do 36.652 feet, this will be my approximate rounded answer to the nearest thousandth. Because after this 5, it was originally a 1, and the following number was a 9. Now, the rule is, if it's 5 and above, we give it a shove. We add a 1 to the previous digit. If it's 4 and below, we leave it alone. So that means we ignore anything after that digit, and we keep. Okay? So this will be your approximate answer. Let me raise it up a little bit. This will be your approximate answer, and this will be your exact. So what happened to pi? I put it into my calculation. So that's what happened to the pi. Okay. Yes. All right. So pi is P-I, not P-I-E. It's not a piece of pie. Yes, this number included my pi. Yes. And I didn't just use 3.14. I used the entire pi. So if I put it in my calculator, I actually look for the symbol of pi. So I want to get as many as their digits represented as possible. Okay, cool. All right. So keep in mind how we found this. So for us to find the arc length, we basically take the theta that is given, or sometimes found, over the total circle, and we multiply it by its circumference, because we're getting the length of the outer part of the circle. So if you want to think of it almost like a pizza, you want to see how big is the crust, right? So like if you wanted to make your own stuffed crust pizza, I don't know, but and you just want to figure out, okay, well, what would be the length of that crust? That's what you're doing. Okay, so you would do that. Hey, I would love for you the next time you get pizza, if you're one of those type of people that get pizza every Friday night, hey, let it happen on one of those Friday nights. And then maybe take a string that goes around your piece of crust. Then you elongate that string, take a ruler, measure it. And then I want you to calculate. So what will be, okay, you measure the length of that string. What will be your radius? So what will be half of that measure? That will be your R, okay? And then you probably have to figure out the degrees. If you have 8 slices, think of it this way. You got what? A whole pizza is like, say it's a circular pizza. I know I don't want to, assume, but say it's a circular pizza. And there's like roughly 8 slices. And we all know they don't cut the slices evenly, but just hypothetically, right? Entertain me a bit. So if you divide those by 8, we're looking at each of the angles when you go to the center of that pizza should measure about 45 degrees. All right? So if you want to have fun with that, knock yourself out. Be good fun times with him. Apple pie. Okay. All right, so right now I'm not doing sine, cosine. That was before. Okay, so now I'm looking at arc sectors. So sectors is basically the slice of pizza itself, right? So you have a whole pie, and now you want to get a slice of pizza all to itself. I don't know why it got a little blurry, but here we are. All right. So we know that, I'm going to put it over here. We know that the formula for finding the area of a arc length was your theta over 360, and you multiplied it by the circumference of the circle. But now we're looking at an actual piece of pizza. Like you got the pie open, you lift the lid, the steam, hopefully the steam is coming off of it, and you're taking your slice. You want to get the area of that slice. So the way you do that is you're going to be looking at the area of a circle. Okay? So for you to find your sector, it's the same formula with your theta over 360 because you're taking part of the circle. But now I want to know what the area is that. So if you want to know the area, you're going to use the area of the equation. All right? So now we have our situations. Let's take a look at 12. So they want us to find the radius and circumference. So, I haven't gotten to that part yet. Sorry. We want to find the radius and the circumference of this. So if they want the radius and circumference, obviously we're not at area yet. Okay, kind of jumped ahead. So if we need to find radius and circumference, that means I'm using my theta, my 360, times my 2 pi r. Okay? And they're giving us sorry, I was getting a weird message. And they're giving us our arc length. So they're telling us that it looks like from D all the way to E, which they should have given us another point because that should be a major mark. So I'm going to give us one. So I'm going to put a G here. Okay. So if I say DGE, okay, because if I said arc DE, I'm talking about the minor arc. If it's a major arc, it should be 3 letters. So they're telling us the arc length. They already gave that to us. So I'm going to substitute that out here. 46.75. Okay. Then they gave us what the degrees is for that arc length, which was 290. So we're not using what's happening in here. We're using the one that gave us the arc length. So that means you have 290 over 360. Okay, times 2 pi r. And the reason why we're leaving it as a r, they didn't give us the radius. And that's one of the things that we're looking for. We're looking for that radius. So we're going to do a little bit of reverse algebra to figure out what is A, our circumference, and B, our radius. So it'll be a lot easier if we figure out what is 290 divided by 360. And it should be a nice long decimal. And if you don't want to do 290 and 360, remember, both of them end with 0. You'll get the same thing if you say 29 divided by 36. So what do we think? Okay, so it's going to be a long decimal. So if I have my 46.75 and I'm subtracting that answer on both sides, so if I take that 46.75 and I subtract that very long answer for a decimal, I'm roughly going to get 45.9 with my 4s repeating. That's what 2 pi r is going to represent. Okay, so that's what 2 pi r is going to represent. 2 pi r sounds familiar. 2 pi r is your circumference. So you can honestly just sit here and say, oh, well, my circumference is going to be 45.94, and they used feet for the circumference. You already solved it. So you're probably like, oh, I got to do all this solving. Well, you still have to solve because we need to figure out what the radius is. But the 2 pi r is the equivalent, or is the formula for circumference. So you already found the circumference of the circle. But now we need to find the radius. So in order for me to find the radius is 2 pi r, aka 2 times pi times r. So now I got to divide both sides by 2 pi. And the reason why I'm doing that now is because I'm trying to find the r, the radius. So now, here comes the handy dandy calculator. So you already got your answer. We're going to divide it by 2 pi. Now, my suggestion, I like to use the whole amount of pi instead of 3.14. But if you want to leave it, you can leave it. Okay? I know. I know. I didn't make this up. But at the same time, that's the one thing that kills me. How can we sit here and talk about the major arc if we didn't have the third letter? So I'm just using this to find it as a pattern. Okay? So by rounding to the nearest hundredth, I get an answer of 72.169, which is rounded to the thousandth. But if I need to round this to the hundredth, it will be 72.17. And the length of that will be feet. And I know it doesn't make sense in reality. I just want you to get used to the rhythm. Hell, everything nowadays doesn't make any freaking sense. Anyway. All right. Okay. So, if they give you any kind of wild card, that's what's happening. Now, to go into the area of the sector. Now we're looking at theta at the 360. But this time it's going to be times your pi r squared. So here I got 3 different examples, but we're just going to go one by one. So they're giving me my theta, which in this case is 65 degrees. Let's see if I can zoom in just a bit so you can at least see the indentation. All right. So they're telling me that my theta is 65 degrees. So it means 65 out of the 360. Now, since we're looking at the area, so it's almost like that whole pie slice, pizza, apple, whatever. All right. So you're taking your pi times your radius. They gave us the radius, which was 4 inches. So we are squaring that. Because even if the radius is over here is 4, that means radius of CB, that's also going to be 4. So when we're looking at the area, we're looking at the shaded area. That's what we're trying to find. So now you have your 65 over your 360 times 16 pi. And the 16 came from 4 squared. 4 squared is 4 times 4. The radius of what? The radius of the circle. Okay. Okay, so were you here for the beginning part? Probably not. So, we're looking at the radius of the circle from the center point to a point that is on the circle. They're giving it to me as 4 inches. So we're using this formula to figure out the area of the shaded region. So that means we have our central angle, which is 65 degrees. So 65 over a total circle. The whole entire circle is 360. Okay, are we good so far? Yes, no. Okay, I got a yes. How about 125? Are you with me? Okay, Apple user, yes. Okay. So now we're going to plug in the radius. The radius is the 4. So the 4 is going in for the R. So the R is 4, and then we're going to square it. So 4 squared does not mean 4 times 2. When you're squaring it, you're not doubling it. Okay? You're taking a number multiplied by itself twice. So that's 4 times 4. That's where the 16 comes from. Okay? And the pi just comes down. I want to put my answer as exact can be. Okay, so that means I'm not using 3.14. So now, we're dealing with a fraction being multiplied by a whole number. So we can do this one of two ways. We can either multiply the numerator with the whole number, or we can simplify the 16 over the 360. So since 16 is even and 360 is even, I know I can either use 2, I can use 4, I could probably use 8. I think I can use 8. Yeah, I can use 8. Because if I take 16 divided by 8, this 16 is now 2. If I take my 36 and divide that by 8, that now is a 45. So by doing the cross simplification, I'm kind of lessening how much I need to do for the multiplying. So I don't have to deal with thousands, place values. So this turns into a 65 over 45. And this turns into a 2 pi. Now, this seems a little bit more manageable. Okay? Okay. What do you mean, can I add a 1? Okay. Okay. So now we have our 65 and our 45. So like Lisa kind of mentioned, it will work with 5s. So if I want to, I can simplify this. So 65 divided by 5 will give me what? Yeah, I'm not adding the 1 because that's 16, not 1 6. Okay. Because this will give me 13. Good, NC. 45 divided by 5 will give me a 9. So now I got 13 over 9 times 2 pi. So now all I have to do is just multiply the numerators. So 13 times 2 will give me my 26. And I bring my pi, and all that's over 9. So the area of that sector is going to be, what are we talking about? Almost forgot. Inches square. All right. Yes, because it doesn't. You're going to get the same answer. Now, especially if you have to do this manually, I don't know. I don't know what the situation is going to be. I'm not sure if it's going to be, if there's a tested area on this section. If not, I think SAT probably has like 1 or 2 of these because this really is being in Algebra 2. So, but anytime, like I like to show some of these advanced problems because these are what some of my students are going through now. So you can see where the basic concepts are coming from. You're still using those. Okay? So if it's not a timed assessment and you can take your time to reduce, go ahead. Take your time and reduce. I don't care if you have to do how many pages of paper. All right? Yes. I could have reduced that one too. Yes, I could have. So I could have reduced it right from the very beginning with the 65 and the 360 if I wanted to. I think I can do that by 5. Okay? Or even lower than that. Okay? So how do you enter this information into a calculator? Well, you type in your 26 if you're looking for the approximate answer. If you're thinking, oh, let me just put all this in one clean swoop, go ahead. But you definitely going to have to put parentheses. Like if you are going to put it all in, put this fraction in a parenthesis, have your pi, and then have your 4 squared. Okay, the powers of parentheses is huge. Because if not, your calculator is going to just put it all together and then you're going to get an answer. It's not probably going to be right. And then make sure your units is inches squared. Okay, yes. All right. Okay, so now for the next one, we're trying to find the area of the shaded region. Okay, so they're saying that the arc measure of BD is 130. Does it mean that the measure of angle C is also 130? Yes or no? And I accept question marks if you're not sure. But don't use it as a, yeah, I don't know. Think about it. okay, is the arc measure, which they're giving me as 130, is it the same as what angle C is? Okay, so Lisa's saying yes. Okay, Nicole is already setting things up, so I guess she's saying yes as well. And then Nicole, why'd you change your answer? Okay, film artist is saying yes. Okay, Georgia born raised is saying 70. Where are you getting the 70 from? I'm just curious. Okay, I wasn't sure. All right, stick with one answer and stick to it. Okay, no wish, no wash. You got it. Trust yourself. Okay, gotta trust yourself. All right. So the answer is going to be, okay, so we have rushing. So where's the 230? Or were you just rushing? Yes, is the same by definition. Yes. Okay. So anytime you have a central angle, and this is your angle measure, not your arc length. I have to emphasize that. Too many people lose points because of that. So that means that this is 130. That means our central angle is also going to be 130. So just like Nicole put down, it's going to be 130 out of the 360. And now, since we're looking at the area of that section, it's going to be your pi, your radius squared. Now, what is my radius? What is my radius? Okay. Okay. So just the good. Nice. So the 27. Okay, that's my radius. So we're putting that 27 in. So before, remember, please excuse my dear Aunt Sally. So the parentheses, we don't have anything inside the parentheses to do, but we need to square it. Okay? So we need to square it. Okay, Hashan, I think that's your name. I see your answer. But see, here's my thing. There is, 35 people in here. And I want to respect almost everyone. It's great that you got it, but there might be some others that need a little time. All right? If I'm too slow for you, there's tons of other people. My favorite person, she's going to be coming on in like 10 minutes. So if you want to check out Impact Math 19, you're more than willing to do that, okay? All right, so right now, I'm not ignoring you. I see you. So, cool your jets. Thank you. So, 27 squared. What did we get for 27 squared? I think we got that. Thank you. Here we go with the 729 pi. Now I understand because there's a lot of other people, there's a lot of other platforms, and you just feel like people are ignoring you, so you feel like you got to shout it out. All right? All right? So, do we always put the radius? I like to put the radius in parentheses just to remind myself that I got to square it and not multiply it by 2. That's the reason why I do it. Okay? So, I will. So now, thank you, Lisa. That's why I was like, right here, you got 130 divided by 360. They're both ending in 0. So instead of dealing with large numbers, we can cancel out those zeros. So then actually you got 13 over 36. So you're probably saying, let's say, can we basically simplify the 229 with the 36. 9 and 6, that means we're dealing with something with multiples of 3s. But I have a feeling 9 can play a little bit with it. Let me see. Yep. Because 729, if I divide that by 9, I think I get 81. Yep, I do. So this will turn into an 81. If I divide the 36 by 9, I'll get a 4. And then at 13, that was my numerator, that comes on down. So now you're not dealing with thousands and hundreds and all that stuff. Thank you. All right. So by doing this, sorry, I forgot to put it over here. Okay. So if I take that 729 divided by 9, gives me 81. All right. So boom. If I take my 36 divided by 9, I get my 4. So boom. So don't forget to bring down the pi. I like to keep my answers as exact can be. All right? Yes. So don't divide, reduce. Yes. If you see numbers, like say if it was, I don't know, if it was, I don't know, 360 over 360. All right, go ahead and divide that, you know. But I tried to simplify it as best as we can. Well, hello. Sign and symbols. Okay, what are we working on today? Yes, we're finishing up. This time we're doing the area of sectors. So now, I know if I try to do 81 and divide by 4, it's not going to work because 81 is odd and 4 is even. Okay, so we're definitely going to be getting some decimals. All right. So now I can multiply my numerators. So if I have my 81 times my 13, gives me a lovely 1,053. Okay, keep that pi and put it over 4. So if I try to divide this over 4, I am going to get a decimal. Okay, and if you want to get a decimal and put it tack with next to your pi, you can do that because it's not a very long decimal. Okay, yeah, you kind of want to look for GCFs, but since this ends in an odd number, this ends in an even number, it's not going to give you anything. Okay, so that's why I always kind of look at the last digits. So if you want, you can leave it like this for the exact. Okay, if you want it in decimal form, because it's not a very long decimal, it's only when they have those continue on decimals. That's when you want to. And I tack on my pi. I'm going to put the word or, because these answers are acceptable. Okay, but if you want to multiply this and get the approximate, okay, so these are more the exact. I'm going to write the word exact on the top. Okay, but if I want the approximate, you actually multiply the pi. And when I multiply the pi, oh, I get this lovely, lovely little answer. So 827. And it all depends if you're trying to figure out like, well, which answer is the true answer? Well, if they say exact, you can go either or. Okay, because we didn't have to round this decimal. That's exactly what 10,053 divided by 4 gives us. And you just leave it in terms of pi, aka just leave the pi. Don't worry about 3.14. But if they want approximate, okay, this included my pi. When I calculated this with pi, this is what I got. But if they say round to the nearest thousandths, So this is your tens, that's your hundreds, this is your thousands. So that means we need to look at the next digit. Okay, we need to look at this next digit. We need to look at the 2. If it's a 4 and below, which it is, that means these numbers before that thousands disappear, and then you just focus on what remains. So your final answer, since this is in, almost forgot. I have a tendency to do that. Okay, since it's area, it's going to be your centimeters squared. So the approximate is 827.024 centimeters squared. And that's your approximate, rounded. Okay. I know, try to keep it entertaining. Yep. All right, not a problem. Okay, so I do have time for one more. So we kind of walk it through step by step. If anything, I'm going to give you time to set up. Then I'm going to ask you, does your setup matches mine? Then I'm going to give you time to get your answers, but I'm going to ask you to just type in, but do not hit send. I want us to release all our answers roughly at the same time, okay? Just so to give everybody time to process. All right, how does that sound? Okay, if that sounds pretty good, go ahead and tap the screen. Let's kind of raise this up just a hair. Or if you don't want to tap, you can say the word okay. You can give me a thumbs up emoji. You know, I'm not a tapping hog, but it would be nice just to make sure that TikTok knows I'm here. And if you know anyone that needs this information, go right ahead. Please share the like over. You can share the live. You can just share it. I'm always sharing because at the end of this, I'm going to share so you can take screenshots of my work. But I'm also going to say that all my lives, some of them, a good majority of them, are on my YouTube channel, and I'm going to share that information with you after this last problem. So if you need to see any of my lives, and you're like, oh, someone asked earlier about sine and cosine, and they're like, oh, I can't remember which one is which. I'm going to see if I just start releasing all of my stuff so you can just get it. And you take it at your leisure, okay? Because I'm going to be creating tons of stuff. All right? Okay. All right. Thank you for the tapping. I appreciate it. Okay. So let me give you time. Thank you so much. Let me give you some time. So this is the situation. Okay, let me give you some time to set it up. Okay, I'm going to give you about, is 3 minutes too much? Let me give you like 3 minutes for you to set it up. And if you want to continue on with solving, you can. Actually, 2 minutes. Are these problems in your workbook? I am working them. I am putting them in my notebook. Yes. But I do not have a individual workbook. Okay. It's funny as you're watching time, you're like, It's really not that bad. I think I can do it in 1 minute. Okay. All right. Is your setup like mine? All right. Excellent. Now keep going. Okay. If your setup's like mine, awesome. Keep going. If not, take a look to see what tripped you up. Oh, well, thank you. Good, Lisa. Good. Oh, well, thank you. I appreciate that. Oh, thank you for the roses. I appreciate this. How could you tell I really needed it? Because it's been a day already, and it's just 2 o'clock, or after. All right, so keep going. And then remember, hold your answers. Probably like the next 2 minutes, we'll take a look. Yeah, thank you, film artist. That's been. But good days is coming, right? Good days is coming. Hey, Jocelyn. I'm actually doing it with you guys. This is the one I didn't do an answer key for. Most of the time I don't. Hey, Anne. Yes, I'm going to try to stay optimistic. Oh, thank you, Anne. Thank you, thank you. I know, I will, as soon as I can get a moment. All right. In about 15 seconds, we're going to show our answers. Let's see what we got. about 19. Oh. Oh, 209. Yeah, 209 will be your angle or your arc measure. Okay. So did I already screw up? I think I did. You're so right. Thank you, Pog. Sometimes I wish I knew what your guys' real names are. But I understand. I will respect the space. That makes sense because I was getting a funky answer. All right. Okay. Let me zoom in just a tad. All right, so since they gave us the arc measure of this arc, which was 209, but we're looking for this part. So in order for us to do that, we got to take what the measure of the whole thing is, which is 360, and subtract by the 209. Okay, borrow from the 6 to make that 5. So that gives me 151. Okay, so it should be right here, 151 degrees. So it's going to be the 151 out of the 360. That's why I screwed up on. But our radius is 18, so it's 18 squared. So now, just go ahead and make changes. Lisa, you saw what I did. I screwed up. I'm sitting here putting 209. I'm like, oh, everyone's fine. Yeah, so please do not fret. So we have our, 151 over our 360 times, thank you. So we have our 324. Thank you. Thank you, Nicole, for the 324 pi. So now, 324 and 360, they're both even. So it's kind of telling me that there is something it can be reduced to. So let's see. That would give me 9, and that would give me that. So 36? Yep. So this, if I divide this by 36, and I divide this denominator by 36, 324 divided by 36, that will give me 9. Might be a little easier if I put it in a different color. So this will be 9. So 360 divided by 36, that will give us 10. Because I knew I couldn't reduce 151 by 360. 151 is odd, 360 is even. Yeah, not really. We're not going to get much. So that means we have our 151 over 10 times 9 pi. So it makes it a little bit simpler, okay, just a little bit. So now I can multiply straight across because again, 151, that's odd, 10, that's even, and it's tough to reduce that. So we have our 151 times 9. So that gives us our 1,359 over 10. And don't forget the pi. So you could leave it as that lovely fraction, or you can basically divide this. I'm going to put the or. So you get your 135.9 pi. And the measurements that we're dealing with was squared meters. Okay, so this, I think I have room, let me slide over. This is our exact answer. Okay, so if they ever ask, what is your exact answer? That means you're leaving it in terms of pi. Okay. All right. Did something happen? Wait, what happened? What happened? Okay. Oh, okay, that was the old one. Okay. So if I want to put it in terms, or basically approximately, so the approximate symbol is like an equal sign with but they're two waves. So that means I'm incorporating the pi. So if I take this answer and times it by pi, I'm not doing it by 3.14. You could, but if I put it in terms of pi, I got this lovely answer. So 426 times 942, double fours, 16. And we need to round this answer to the nearest thousandths. So that means I'm looking at my 10,000ths. And if it's a 4, which it is, that means I am eliminating this part and just keeping everything. So I'm not adding 1. So my official answer is going to be 426.942. And this was squared meters. So this is the approximate answer. Okay. So not only are you learning about the area of the sector, you're going to be looking at pizza different now. You're going to be looking at cake now. You're going to be looking at anything that gives you a circle and you're trying to take part of it, a part of that circle. You're going to look at it different now. Okay. Go to your next party and have like a whole thing. Have everybody like do measures and stuff like that. Okay. All right. Maybe not. But that's basically how you find the area of the sector. Now, the key part, I'm going to see if I can unzoom so you guys can take your snapshots and everything. Okay, so let's see if I can get it. Oops. All right. All right. So if anything, do you always subtract 360? If you know part of the circle, excuse me for a second, guys. If you know part of the circle, but you're looking for the other part of the circle, that's when you subtract 360. Okay? Because you only want to get this section. So think about it. These are your 3 slices of pizza, right? You're mad hungry. You want some food, right? So you don't want to calculate the area of what's left. Because let's be truthful, we don't care how much pizza is left. We just want to know what's on our plate. So we want to take the area of what's going on to your plate. So that's the only thing. Yeah, if it's not shaded, right? So if it's not shaded, yes, we have to do the 360. Okay. So that's this side, and then this is what we worked on yesterday. So I'm going to put that up, I think. I know it's really hard for me to put everything in. Oh, wait. I think I might got it. I think so. Let me just take a quick little snappy shot. But again, the instruction on the arc measure, that is on my YouTube channel. So I try to download all of my lives. Sometimes it takes me some time because sometimes it takes some time for it to load. And that's always a joy. No, it's not. That's the one thing about trying to do these things. That's the pain in the neck. Okay, not a problem. So, couple things. If you can, I would greatly appreciate it. I think I put this up earlier today, but I'm not even sure anymore. Okay, so if you can, and I know some people are like, yeah, what is the symbol next to pi in the top? Next to pi at the top. The circumference? Oh, pi d. D means diameter. So this thing here. Yeah, so you can get circumference 2 ways. You can either have pi times the diameter or 2 pi times the radius. Okay? Because remember, the diameter is twice the radius. Okay, not a problem. So, I know people are like, financially, Audrey, I cannot support you, but these are some other ways that you can support me. So if you can, because this is basically tutoring, basically, there's a lot of prep for it. So if you can go to Google and you can type up and look up ACG math tutoring, and if you could put a Google review, I would greatly appreciate that. I would love to get 100 reviews before the beginning of the next school year, which is tons of time. But the more that parents see the results and the reviews, and people are just like, oh, I love how she does this, and she does it on TikTok or whatever you want to write down, I would greatly appreciate that. So that's one. The other thing, if you can subscribe to my YouTube channel. I don't know what's going to happen with TikTok. This is part of my worries because I really do enjoy coming to TikTok and really, helping as best I can. All right. Thank you. If anything, if you can come and subscribe to my YouTube channel, because I think YouTube is going to be here for a long time. Plus, I'm going to release all of my lives that's on there. So you can just go nuts binge watching. But I put it in raw and uncut. I know that sounded so gross, but here we are, and there it is, right? But I don't like to cut it out. But I do have some of the clips that I use for my shorts. But there are going to be some things. It does take some time for it to upload, so just keep that in mind. So again, go to Audrey Codner, ACG Math Tutoring, and you'll see my face with my logo. Now, right now, because I have to get clients, I need money, especially to get myself ready for the summer, because the summer months, I generally don't have a whole lot of students. So, but I'll be thinking of something to do, and I got my courses and I have my notebooks and everything. But right now I'm looking at Tuesday nights at 8:30. I'm trying to block that off for you guys. Wednesdays at 1, like we did today, and then tomorrow at 1 as well. I am going to try to see if I can do something maybe on a Saturday. Sunday, it might as well, because a lot of my kids are starting to go on spring break. So if I do need to just jump on, I'll probably put a post out that morning to say what time I was going to come on. It might be in the afternoon, because I know some people like to go to church. And, some churches are a lot longer than other. I'm Catholic, so I do the early mass because I can be done in a half an hour. Truth, but I still praise God every day, okay? So I'm just really being as real as I can be. If by chance, so if you want to take a snapshot of that, you can. If you're new and you're just like, oh, I kind of like that little notebook setup that Audrey has, awesome. Sundays, 4 p.m. Oh, look at you. Well, wait, no. It's either going to have to be earlier than that or later than that, because I have a kid that came back from spring break. So I'm thinking like possibly like 5:15 or 5:30, possibly 5:30. Okay. So it might have to be later. So this is the math notebook that I actually designed. I have like different covers and they're all on Amazon. And I just kind of like to take either some of the stuff, you can draw your own graphs, or if you get pieces of paper, you could just tape them on into your book, and then you could write your notes to it. The one thing I really like is the formula section and also the step section. So although you have like all your information here, you also have like space on the other side, which gives you a regular grid that you can do either more practice problems with it, or if you have a piece of paper that's given to you by your teacher and they said keep it in here, you can actually summarize the stuff on the other side so you can keep track. So you get 100 pages of those. But if, say, multiplying, when we were kind of doing the reducing of the fractions and we're trying to look at the factors, I have this factor sheet from 1 to 200. Okay, and it gives you all the factors of it. Anything in red is good for simplifying radicals. All right, that gives you that perfect prime combination. What's in blue is our perfect square roots, and what's in yellow is your prime numbers. So it's just kind of easy to kind of keep track of, as well as what are those most popular words used in word problems to help set up your equations, your rules of integers. There's also things with the equation of the line, and then we have order of operations. We know it as please excuse my dear Aunt Sally, but some international students know it a little bit different. So both is being represented, as well as exponents, transformation with some geometry. Then we have, hey, this is what we worked on today, the area of sector, their arc length, if you ever get stuck with it. We were working with them in degrees, but there's also something called radians. So I didn't want to confuse you, so I just kept it with one at a time, all right? As well as your area of the circle and circumference, all right? So Pythagorean theorem, the unit circle. When you get into Algebra 2, this is going to be your new best friend. Okay, second semester, as well as some brain breaks. We all need a moment to kind of decompress, just do something mindless, and then before you know it, it's time to get back to work. All right, so that is basically my math notebook. If you want a copy of it, it is on Amazon. I'm working on another alternative. Yes. That time? Okay. So Lisa's like, yes, 5:30. Let's do 5:30, girl. Let's do it. All right. So if anything, that's what we have. This is one of the notebooks. And this one is the most popular one because of the cover. My first book had all this. And again, this is the blank one, the newest one. And if you have kids that are in 4th or 6th grade, I have a smaller version for them, a little gamified in the front. So they can actually got math tables, math tiles. So it's easy for them to line up their numbers. So they get used to the ones, the tens, the hundreds. They also get a review, the resource part of it, as well as we're looking at fractions. What is a fraction? Couple examples of fractions that they can use for activities. Then the whole transformation from a percent to a decimal and so forth. Fractions operations, as well as the place, decimal operations, talking about long division. Oh, this one's always fun. Conversions. All right. They also have the same order of operations. And but I gave them an example of a word problem. And then a couple different brain breaks. All right. So these are all on Amazon. Your girl has been busy. So if you want, I have courses. And a lot of my courses, it's easier for me to do it this way. I know, it gets very salesy after a while. All right, so I do private tutoring. I have right now, legitly, without me rearranging, I have 3 slots available. All right, so, but at the same time, just for my TikTok people, don't forget, I do have that study groups. That's going to be on Monday. You just have to go onto my website and then click anywhere on that page that talks about TikTok study group. Okay, so if you want that, hey, is this Ruth? So if you want that, you have that as an option. Okay. So I also give courses, GED math, ASVAB math, ACCUPLACER math, and also algebra foundations. Something to think about if you're thinking about staying at home for the summer and maybe you have a kid that's about to go into algebra. This will be perfect for them. If you're thinking about going into the community college and you're thinking about taking your ACCUPLACER and you really want to review on it, you can do the algebra foundations or the ACCUPLACER. Either one will work for you. But if you go to my website, ACG Math Tutoring, or just go to the profile of my page, if you go to that profile, click onto my picture, go to my website, and you can go right to it. All right? Whew, that was exhausting. Okay. So, again, a couple things that I need from you. If you can give me a Google review, I would greatly appreciate it. That will help me bring in more people. So the more people I'll get with this, I'll hopefully be able to rearrange it so I can still be here on TikTok. I don't want to completely abandon you guys. All right. Then subscribe to my YouTube channel so you can get all of the lives. I actually made a playlist for you guys that says TikTok lives. I know it's really deep, right? I was really like, oh, what can I name it? TikTok lives. Like, keep it simple. But then you can also take a look at some other things that I do on there as well. And then again, I will be here tomorrow at 1:00. And then I'm going to add this in. Notice I'm trying to pin it. So I'm thinking about Sunday at 5:30. I'm going to try to do that. Okay. So at least there'll be at least one other time that we can see each other. I don't know. There's times that I just can't sleep. So I might be one of those crazy people that might come on to do math like at 10 o'clock at night. I don't know. I don't know what's happening. So we'll see how it goes. But this, let's see if we can go with this. All right. I will begin next month. Okay. All right. Oh, hey, Ruth. All right. So everyone got that one. Awesome. So I think that's it. So if there's anything that you guys need, please. If you know someone that is struggling, they're taking those community college classes and they're just like, I have this person. Don't keep me a secret. Okay? We have to stick with each other in order to build each other up. I'm sorry. That's it. All right? So the powers that be, they're losing their minds and I can't. I just can't anymore. And I think it's emotionally sucking the life out of me. But all I can do is just to stay true to myself. And I want you to stay true to yourselves. Be proud of yourselves, the fact that you are here, that you want to learn, even if it's just for fun. right? It's kind of fun that way. All right. So have an amazing day. Oh, Lisa, thank you for sharing the lives. Thank you for sharing the lives. Thank you for the taps. My goodness, like 6.6 is awesome. So I will definitely see you guys Thursday night, unless my 8 o'clock person stiffs me. It's been an ongoing theme that way. I might come on tonight. We'll never know. We'll never know. Here's us hoping. All right. Have a great rest of your day, guys, and I will see you soon. Take care of yourselves. Bye.